Chapter 6: Sensation and Perception. We rely heavily on our senses to make our way in the world. Sensation is the process by which the nervous system detects the physical events around or inside us. We use sensory cells that are specialized to detect sounds, sights, and smells around us, as well as the position and movement of our body and the aches and pains inside us. Perception is the experience we have as we process and interpret information from sensory cells. Percept is the final interpretation of a stimulus. Sensation begins with a stimulus. A stimulus is any physical event that affects our sensory receptor cells. Sound waves are a stimulus for our hearing. Light is a stimulus for our vision. Sensory receptor cells, also called receptors, are specialized sensory cells that detect stimuli. Each kind of receptor cell is specialized to detect a particular kind of stimulus, such as sound wave, light, or odor. Sensory receptor organs are a clump of receptor cells, all detecting a particular kind of stimulus, such as in the eyes, ears, tongue, or nose. Audition is the process of hearing. Olfaction is the process of smelling odors. Sensory modalities are the different types of senses, such as vision, hearing, taste, touch, and smell. Adequate stimulus are the type of stimulus for which a given sensory receptor organ is particularly adapted. We are also dependent upon the vestibular system, which gives us our sense of balance. Labeled lines are the concept that specific nerves are detected to relay specific types of sensory information to the brain. All detection systems have thresholds. Each type of sensory stimulus can vary in intensity. Sensory code is the relationship between stimulus and the action potentials they produce in sensory cells. Threshold is the weakest possible stimulus that still affects a sensory cell's firing. Really weak stimuli are below threshold, so they have no effect on the receptor. Stronger stimuli are above the threshold, affecting the receptor signals to the brain. A stimulus that is just barely strong enough to affect the receptor is the threshold stimulus. Psychophysics is systematically analyzes perception. Psychophysics is the study of how physical events such as light and sounds affect our senses. A psychophysicist will systematically change the intensity of a stimuli, such as the loudness of a sound, and then ask a participant to report how he or she experienced that sound at each intensity. Psychophysicists systematically measure the frequency at which a person can detect a stimulus of a given strength. Absolute threshold is the lowest intensity of a stimulus that can be detected half the time. If the stimulus is much stronger, the person will detect it every time, and the stimulus is said to be above threshold. If the stimulus is so weak that people detect it less than half the time, then it is below threshold. Psychophysicists also measure the just noticeable difference. Just noticeable difference, JND, also called difference threshold, is the smallest change in magnitude of a stimulus can be detected. Weber's fraction is the smallest change in the magnitude of a stimulus that can be detected, expressed as a proportion of the original stimulus. Detection involving finding a signal in a background of noise. Because sensory systems are so sensitive, with such low absolute threshold and the ability to detect very small JNDs, all organisms are faced with a problem. A false alarm occurs when a sensory cell said a stimulus hit it when there was no stimulus. Noise is a firing of a sensory cell without a stimulus or to an irrelevant stimulus. Signal detection theory is a way to measure how well a real stimulus is detected in the midst of an irrelevant stimuli. There are two ways in which a signal can be correctly detected. One, we may detect a signal that is real, which is called a hit, or we ignore noise that is unimportant, which is a correct rejection. There are two ways we can be mistaken. We might ignore a true signal, which is called a miss, or we may think there is a signal when really there's only a noise, which is a false alarm. A stimulus that doesn't change is unimportant, so sensory systems ignore it. Sensory adaptation is the progressive loss of responsiveness in sensory cells exposed to a constant stimulus. 6.2 Touch and pain. The body is covered with nerve endings that are specialized to detect physical events on our skin and internal organs. Touch sensations are conveyed by various receptors for light, touch, vibration, temperature, and tissue damage. Each receptor has a different receptive field. A receptive field is the region of space where stimuli affect the activity of a cell in a sensory system.